Okay, good morning, students. So we have completed the chapter 15. Now we are going to start the next chapter, chapter 16. So it's very different chapter than the other chapters. Majority of the topics are more related to physics. So do you know the spontaneity, entropy, and free energy before? So it's very amazing topics, and I think you have some idea about this one. Especially the entropy, it's very complex topic, very difficult to understand, but I will try my best to explain this one. So in this chapter, basically, we will learn the three things: the spontaneity, entropy, and free energy. So the contents are the same three things. So first you will learn what is the spontaneous process and entropy, what is their relationship. Then you will understand, I will teach you the thermodynamics law, first, second, third. Maybe I will also introduce the zeroth law of thermodynamics, which is not part of the syllabus, but I will introduce this one. Then you will understand what is the free energy, what's its importance. And you will learn how to calculate the entropy change in the chemical reaction, free energy change in the chemical reaction, and the factor which affecting these energies or these parameters. So, students, before going to this detailed lecture, first I would like to review the thermodynamics. You know what is the thermodynamics? Any idea? Any student? What is the thermodynamics? Thermo means heat, dynamics means motion. It is sometimes in chemistry we say thermochemistry, thermodynamics. So it means heat and motion. So students, whenever you convert one energy form into another, for example, the bulb, it convert electrical energy into the bulb, light bulb, it convert electrical energy into which energy? Light energy, light. Okay. So similarly, the heater convert electrical energy into heat. So there are many devices which convert one energy into another energy. Battery convert which energy into which? Chemical reaction takes place. Chemical energy convert into electrical energy. So students, whenever you convert one energy into another, some machine is needed. Mostly we use a machine. So all energy cannot be converted into the other form. Some of it is converted into form of heat. Heat is always involved in energy conversion. So it means thermodynamics is the study of interconversion of energies. Okay. But in chemistry point of view, thermodynamics is it is the heat change during a chemical change or physical change. Okay. Then a change takes place. Change means in chemistry maybe physical or chemical. For example, melting of ice. Is it chemical change or physical change? So melting of ice, does it need heat? Yes. So that heat, this is thermodynamics. So when you burn the fuel or methane gas, heat is released during a chemical reaction. So any heat involved, heat change take place during a reaction or during any change. This is called thermodynamics. But literally meanings the heat and flow. Okay. Okay. But do you know the heat? What is the heat? So heat is any idea? Any idea? What is the heat? Students, heat is energy. Any energy which flow due to difference of temperature. For example, if this is a hot body and this is a cold body, okay? When we touch each other, some energy is flow from hot to cold. That energy is called heat. That energy is called heat. So heat is the energy which flow due to the difference of temperature. Okay, but its other definition is the total kinetic energy is called heat. Temperature and heat are very similar definitions. Temperature of this room is means the average kinetic energy of this gas molecules is called temperature of this room. Okay, and total kinetic energy of all this air in this room is called the heat of this. Okay, so heat is the total kinetic energy and temperature is the average kinetic energy. Okay, but we know heat is only, it is a form of energy. It only flow when there is a temperature difference. When there is the same temperature, heat can hardly flow. Okay. So, so what is the energy? When you eat something, they have written it contain energy, 15 calories, blah blah, kilojoule, joule. So, what is the energy basically? Any idea? Its unit is joule. Okay. So, energy is capacity to do work. Okay. If any material has more energy, it means it has more capacity to do the work. So energy is the capacity to do work, and heat is total kinetic energy, or the energy flow due to difference of temperature. And we learn the thermodynamics. Okay. Students in thermodynamics, if you want to explain anything, you need three things. Students, in the board, what are you seeing? This is a photograph. So this is a image. So it's the beaker. Inside, what is inside? So this is sodium hydroxide solution. Students, when you say we heat this one, so in thermodynamics, we use three terms: system, surrounding, and boundary. Okay. So any part of this universe under observation, which you observe, which is part of interest, is called system. So if you are doing experiment in lab, you are observing that chemical reaction taking place here. So this solution is the system. You are not observing this beaker. This is not part of your interest. Okay, it just supports the system, but system is inside. And the wall of this system, it separates system from the universe. So this is called boundary. And this beaker and this air, the lab, you, everything is surrounded. Okay. So what is the system? In this diagram, what is the system? And this is the boundary. And this whiteboard, me, you, everything is surrounded. So students, in thermodynamics, when we say heat is removed, then we have to explain where. From system to surrounding or surrounding to system. Okay. It is very easier to explain where the heat motion direction. Okay. So students, for example, with respect to heat, how many types of reaction? Two. How many types? Two types. Endothermic air and exothermic. In exothermic reaction, heat involved. In endothermic, heat involved. So how you explain in exothermic, heat move from system to surrounding. Easy. And in endothermic, surrounding to system. It means absorbed by the system. In exo, released by the system. Release means it go from system to surrounding. Okay, so it's very easy. Students, the symbol. So when you are heating, you provide heat, enthalpy, work. So how you decide the sign? In chemistry, our main focus is system. So we assign the sign on the basis of system. In physics, the main concern is surrounding. So they assign signs plus minus on the basis of surrounding. So my point of view, due to chemistry, if anything which decrease the energy of the system is negative, if anything increase the energy of the system, then its sign is positive. For example, if heat move from surrounding to system energy increase or decrease. If heat pass from surrounding to system, it means what is the sign of the that heat? Positive. It means when heat transfer from surrounding to system, its sign is positive. But when heat move from system to surrounding, its sign is because system energy decreases. Okay, if I do a work on the system, I press a piston of the engine. So my work is on the system. When I work on the system energy increase because when I do the work, my work converted to energy. So system energy increase or decrease? Decrease. So if the work is done by the surrounding on system, its sign is positive. If system doing the work, so this is the way you can assign the symbol. So now you understand what this mean by this one. Sometimes we write enthalpy change is negative, sometimes positive. Understand what does this mean? It means here heat come from outside to inside system. It means going to the surrounding. Okay. Student, one more term. In previous chapter, we learned a phase. Phase is very helping to understand many properties. In this chapter, state function is very important. Students, if two hikers, they start from the same point and they reach the same point. One follow this path, one follow this path. The red path is hiker 2, the blue path hiker 1. Which hiker travel more, work more? Which hiker do the more work? So it means the work, it depends upon the path. Here we travel more, we consume more energy, we do more work. But ultimate goal is same. He reach the same point, but he do more work. Hiker 1 reach the same point, but he manage it doing a shortcut. This is the shortcut. Students, there are two properties. Some properties depends upon the path, and some properties does not depend upon the path. For example, the potential energy of both hikers before traveling is the same because they are on the same level. After reaching, their potential energy is increased, but both potential energy is same. So if their potential energy is 5, their potential energy is 15, how much potential energy is increased? 10. So it means the potential energy does not depend upon the path. It depends upon the state. When state is changed, you can calculate how much change that property. So any property which does not depends upon the path, but it depends upon the state, that is called state function. And interestingly, state function are always written capital. If I write any symbol small, it means it is not a state function. Temperature is state function or not state function. If I write like this, then it is mean it is not state function. Volume, pressure, work. Work is a state function. Sorry. This is a capital and this is small. So work is State function or not state function? Because it depends on the path. It changes by changing the path. Okay. So only two things are not state function. That is this one. And state function is very easy to identify. They are always written in capital. Secondly, they can be found by simple this formula. So potential energy can be calculated the energy at higher potential state, energy at the initial state. So this is the initial, this is the final. Maybe we sometime write 1, 2, sometime write like this thing. So state functions, their change can be calculated by their initial and final state. So the state function, the function which depends upon the state, not on the path. And interestingly, every function is a state function except two. These are not state functions. Okay? They depends upon heat. Okay. If I am heating this water, 1 kg water, in iron pot, this is made of iron. Iron is good conductor. It heats quickly. But if I heat it in the earthenware, this is earth pot, maybe made of some ceramics material. So it is not a good conductor. If I heat it, heat passes through this path. Water is 1 kg. It takes longer time and more heat to boil. Okay. So it means it depends upon the path. Here path, good conductor, heat pass quickly, easily, effectively. So heat and work, they are not state function. Domla? So what is this? How you determine it is a state function or not state function? All properties are state function except heat and work. Actually, heat and work is the way to transfer of energy. It means if you change the way, energy transfer is also changed. Here you transfer, if I transfer energy through conductor, heat can pass through the conductor easily. If I pass the heat through insulator, it cannot pass easily. So it means heat is the way to transfer energy. So it means if you change the path, the transfer of the energy is also changed. So they are not state function. So they are only heat and work. They are written small letter, small q, small w. So they are just only energy transfer path. So they are called path functions. For example, rain. Rain is nothing. It only transfers the water from top to. Okay. So it is a path. Okay. Students, in previous chapter, you already learned the enthalpy, this term. And enthalpy is nothing. Enthalpy is heat. So today you will learn why we don't say it heat. Because it is not a state function. And this is a state function. So when we apply a condition on it, then it becomes a state function. Any process which takes place at constant pressure, that heat involved is become a state function. It does not depend upon path. It depends upon the state. So that's why this heat is become a state function. So we name it enthalpy. And this is a change in enthalpy. And can be calculated by H2 minus H1. So this is a heat. But this heat is that heat which is absorbed or evolved at constant pressure. So, for example, if I burn something here, the pressure during burning remains constant or change? Pressure of the air. The pressure of, if anything burn in open air, the pressure of the air on this process is same or change? constant pressure. So the heat evolved from that direction, that is called enthalpy. And we learn enthalpy definitions many times. Enthalpy of vaporization, enthalpy of sublimation, enthalpy of condensation, enthalpy of neutralization, enthalpy of formation. Definition is very simple. It is the amount of heat absorbed or evolved when 1 mole of a substance is evaporated, neutralized, condensed, formed, blah, 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 whatever the property. Understand? So it means it is mostly for 1 mole of the material. If a 1 mole crystal form, it is enthalpy of crystallization. If 1 mole water evaporates, the heat required to evaporate, that heat is called enthalpy of vaporization. So we write like this way. And what does mean by this knot? Though, if we put this symbol, what is this meaning? It is standard enthalpy of vaporization. Standard mean what is the pressure? What is the temperature? So standard conditions. If any process take place at standard condition means 1 atm pressure, room temperature. Sometimes temperature, standard temperature is considered to be 0. Okay. Okay. So this is a review. Any question up to now? So students, now we are going to start the first topic, the spontaneity, spontaneous reaction. Okay. Then we understand what is the entropy. Do you have the idea entropy? What is entropy, Vincent? In physics, we say entropy is
the change of the energy in a certain constant pressure.
no, that is enthalpy. And enthalpy and entropy is unusual. Okay. Yeah. But I'm sure you know the entropy. Disorder. But actually, in my course, I only purify your concept. Entropy is not the disorder. Okay. We do the definition like the measurement of disorder, randomness. But actually, it is practically, or actually, it is not this one. Okay. It's a very complex topic. Okay, first learn the spontaneous process. Okay. So students, spontaneous process, before starting this, let's watch the video and then you will understand what is the spontaneity.
A spontaneous reaction is one that occurs without any external intervention under a particular set of conditions.
So this is the definition.
Without any external intervention under a particular set of conditions.
So if any process proceed without the external assistance, it is called spontaneous. So ice melt at room temperature. Do you need to provide heat by external source? You provide the heat or itself it take the heat? Itself it take the heat, okay? So it means it doesn't need any human intervention, any energy source, external energy source, okay? So for example, this multimedia, it's doing the work. Is this multimedia the projector doing work itself or it need external energy source? Yeah, if we want turn off, we just cut off this power supply, electricity. So it work by using external energy, electricity. Okay, car. When car drive, do it need the energy from the external source?
Yes.
You have to be refuel it again and again. You provide its energy from the external source, okay? Okay, you are growing. Do you need the external energy? It's growing. Is it spontaneous or non-spontaneous? Non-spontaneous. Okay, let's deep dig this concept.
A non-spontaneous process is one that requires external forces to proceed.
So in this diagram, it's the heat, but non-spontaneous means any form of external energy. If you go in, it will provide energy from surrounding the system, and some process change there take place, that is non-spontaneous. Okay. If you provide, in other words, all natural processes are spontaneous and human made or human reactions are non-spontaneous. Okay. We made this one non-spontaneous, car non-spontaneous. So any process which is occurred by itself by natural process, for example, plants grow, weather change, rainfall. So it is a natural process, okay? So they are spontaneous. They don't need external energy source.
Spontaneity is affected by conditions such as temperature and pressure. For example, the melting of ice at a temperature of 0 degrees Celsius or below is not spontaneous.
Students, same reaction may be spontaneous and not spontaneous. Who decide temperature and pressure? Okay, if I put the ice here, does it melt? Yes. Okay, if I put this ice in the refrigerator at this temperature. So refrigerator, some refrigerator have this temperature, some are this temperature, some are minus 78. So if I put in this refrigerator, Pingshan, does the ice melt?
No.
Why? Because their temperature is different. So it means in the refrigerator, the melting of ice is not spontaneous. But at room temperature, melting of ice is spontaneous. So it means who decides spontaneous, non-spontaneous? Temperature and pressure.
However, the melting of ice at room temperature is spontaneous because it does not need any external intervention. A spontaneous reaction is usually unidirectional, and its reversal requires an external force to make it proceed as a non-spontaneous reaction.
So this is also chemical equilibrium, like chemical equilibrium. If a reaction is, for example, spontaneous in forward direction, then it is non-spontaneous in reverse direction. So water fall from top to bottom, high to down itself. But if you have to flow water from earth to upside, you need energy. You use a pump to move the water to upside against the gravity. Okay. So its a spontaneous reaction is only in one direction. In other direction, it is non-spontaneous. Okay. And every spontaneous process in one direction is spontaneous, another direction is non-spontaneous.
For example, ice that melts at room temperature cannot spontaneously freeze back to its original form. Spontaneous processes occur due to the dispersal of energy and matter.
So this is the main thing. So this is actually the definition of entropy is hidden in here. Spontaneous process occur due to these two properties: dispersal of energy and dispersal of matter. Actually, this is increasing the entropy. Entropy definition is this one. So later I will explain this one. So spontaneous process occur due to dispersal of energy and matter. Okay. If energy is spreading or matter is spreading, it means it is a spontaneous process.
If a flask containing a gas is connected to another empty flask through a valve, opening the valve will lead to the spontaneous transfer of the gas to the empty flask.
So here matter is expanding, dispersing. This is maybe you can say diffuse from high concentration to low concentration. Here matter is dispersing. When it disperses, energy is also dispersing. I explain you. So this is, for example, burner. Here is a very, very high temperature, maybe 900, maybe 1500 temperature. So when we burn here, the heat is spread throughout the room. Okay. So this heat is spreading. So this is a spontaneous process when energy is spreading or matter is spreading. Okay.
Which will continue until the gas is equally distributed in both flasks. Similarly, if a hot object is placed in cold water, the heat from the object will be spontaneously transferred to the water until the temperatures of the object and the water.
So here energy is dispersed. Here energy is condensed here. It is spreading throughout the system. Okay. Previous example, matter is spread. Here energy is spread. Okay. So any process where matter is spreading or energy is spreading, it means it is a spontaneous.
Reach equilibrium. Spontaneity in thermodynamics does not indicate the speed of a process. The reaction could be extremely fast, like an acid-base neutralization, or extremely slow, like the conversion of diamonds to graphite.
So it takes millions of years. The diamond spontaneously convert into graphite. So thermodynamically, this reaction is feasible. But kinetically, the speed is very, very slow. Okay, it requires millions of years. So in this chapter, it just only predict this reaction is spontaneous or non-spontaneous, but it doesn't tell us the speed of reaction. Okay, maybe one reaction is spontaneous, but its speed is very, very slow. So this chapter, spontaneous process does not concern with the speed. Okay, kinetics, no. It only does reaction is take place its own or need energy. Okay.
Consider the decomposition of hydrogen peroxide into water and oxygen gas. The reaction, although spontaneous, proceeds very slowly at room temperature. Adding a catalyst, such as manganese oxide, speeds up the reaction and therefore increases the decomposition rate of hydrogen peroxide. Although the catalyst enhances the rate of the spontaneous reaction, it cannot make the non-spontaneous reverse reaction be spontaneous.
So students, here is very interesting thing. Catalysts only facilitate if the reaction is spontaneous, it is possible. It just only speed up this reaction. But catalyst doesn't mean a reaction is non-spontaneous if it means it cannot take this on. If you add a catalyst and reaction becomes spontaneous, no. In non-spontaneous reaction, even catalyst cannot be make it spontaneous. Okay. Spontaneous means not possible. If this non-spontaneous means not possible, even catalyst doesn't help. Catalyst only help speed up the spontaneous process. Okay, it's your time to answer the questions. So the first one is, please read this question, then share your answer with each other. Then I will ask them to tell me which of the following statement is false. Read and discuss with each other. Okay, share your answer with each other. And argue if your answer is not same. After the answer. What is the answer of your partner? And your answer is same or different? Okay, I saw. So what is the answer of your partner? Leadership? Leadership. Okay, two. But the other members of this leader are agree with the leader or not? Obviously. No, not believe on your leader. Leader sometimes deceive. So I think second option is not true. It is false. False. So your answer. Okay. Okay, okay. Okay, the first question is this second statement is the form. Catalyst can convert non-spontaneous reaction to spontaneous milk. But all the other statements are true. What's about the second non-spontaneous process? Which of the following is non-spontaneous process? Okay. Oh, I see. See this one. Electrolysis of water. And yes. Okay. Aurora. Wait. By the way, what is the electrolysis of water? What does this mean? You pass the electricity through water. Electricity energy can break down the bond. When water break down, what are the products? Hydrogen and oxygen. Green fuel is produced from this process. Okay. So we need an external source, electricity or light. Okay. Which of the following condition affect the spontaneity? Presence of mechanical force, speed, pressure, or presence of catalyst. Which of the following condition affect spontaneity? If you add a catalyst, reaction is spontaneous. If you don't add, for example, if reaction is spontaneous, if you add a catalyst, still it is spontaneous. So it doesn't affect spontaneity. Pressure, yes. Speed and this are no. So temperature and pressure, they decide the spontaneity. If we change this one, the nature of the spontaneity change. Okay. So students, I think now you understand what is the spontaneous process. So skiing, which direction you use the cable car when you are coming down or going up? Oh, you need a cable car, you sit and then go to the uphill, okay? Because it is not a spontaneous process. Okay, water flow from down to up, shaft to shaft. Water go from down to up. Spontaneous, non-spontaneous. Okay. Current flow from high potential to low potential, high voltage to low voltage. Spontaneous. Okay. Heat flow from cold body to hot body. Heat flow from cold body to hot body. And methane gas burn in air. So burning is a spontaneous or non-spontaneous? Except heartburn, it is a spontaneous. Okay, because this is a chemical reaction. But students, I said spontaneous reaction take place its own. So here is a fuel, here is the air, but it is not burning its own. So it needs a spark. So how you can say it is spontaneous? No, it is not spontaneous. I think so. Are you agree with me? The burning of coal, petroleum, or burning process, is it spontaneous or non spontaneous? Okay, discuss with each other, argue it, and then explain me. Okay, talk with each other. Think. What's wrong with the burning? Nelson, you can explain also. Okay. So yeah. On Daniels. Aurora, your partner. So burning is a spontaneous process and non-spontaneous. Spontaneous. But why it doesn't burn its own? It needs external energy source. So what do you think? Spontaneous. Mhm. Okay. But explain why it doesn't burn its own. It needs external energy source.
After you get
It means some process, they are non-spontaneous at the beginning. Once you start, then it becomes spontaneous. It doesn't mean spontaneous reactions are always spontaneous. Maybe in the beginning, they are non-spontaneous. But they are exothermic reaction. They produce enough energy. That energy can self-sustain. They can proceed the next step. Okay. Okay. Rustling of iron. It takes place its own. This is a chemical reaction of redox reaction. Okay. And photosynthesis.
non-spontaneous.
Is it occur in the night time?
No,
Why?
no light.
No, it need a light. It is light dependent, external source. If we cut off light, it stop. But spontaneous reaction, believe me, if you start seeing, can you stop anywhere in between without external assistance? Spontaneous, once started, it cannot stop. So it means if photosynthesis is in the daytime start, nighttime stop, non-spontaneous. Okay, it depends upon sunlight. Okay. Is this process spontaneous if gas flow here to here?
Yeah. Yes.
And is this process spontaneous if I move gas from here to here? It need a pump. The vacuum pump transfer gas from here to here. External source energy. Okay, non-spontaneous. And at high temperature, heat flow from hot body to cold body. Spontaneous. Students, is this a direct link with the heat and spontaneity? For example, burning of methane gas, it is an exothermic reaction. Exothermic reaction means the reaction in which heat absorb or evolve. Evolve means go to the front. So it produces lot of energy. It means this energy can be used to proceed this reaction. Okay. Is it means all exothermic reactions are spontaneous?
No.
No.
And is this not necessary? Some endothermic reactions are also spontaneous. For example, the melting of ice. So we don't provide energy. It is day or night. If ice is placed here, it automatically itself melt. Okay. So it means some endothermic reactions are also spontaneous, some exothermic are also spontaneous. So this is not the criteria. Okay. Next is the entropy. So you understand the spontaneous reaction, spontaneity. Okay, so please tell me when I am using this mobile. Okay. So, for example, this mobile is contain the battery, everything. When I am using this mobile, does it take the energy from the surrounding? No. That time it is spontaneous process, means self-sustained, it has enough energy. But when it is fully discharged, then we need to be provide the energy. Okay, then it works. It means overall this is not a spontaneous process. It relies on external energy. Okay. So students, okay, can you give me any other natural process which is a spontaneous? So plant grow. Can you reverse it?
No.
So plant growth is a natural process or synthetic process? Natural. So it means your growth and plant growth, it is a spontaneous process, okay? It takes place itself. So weather change, spontaneous, non-spontaneous. Spontaneous. The next is entropy, the most complicated concept. According to book, the definition is simple. The measurement of randomness or disorder, okay? Students in my class, you are sitting in a well-arranged form, okay? You are in crystalline form. When my lecture is off, you will move. Your order is become disorder. Then I only say my class entropy is increased. Okay? So when your entropy is less, you are well arranged. For me, it's easy to convey the knowledge transfer. When you disperse in the university, scatter, randomly move, so your entropy is increased. Okay. So students, okay, answer me. If this is a burner, so if I burn this candle here, energy is very, very dense. Its intensity is very high. If I put my hand, it burn my hand. Okay. But if I burn this candle in this room, after burning, its heat is still in this room. Okay. So if anybody comes to the room and put his hand inside, does its hand burn? Same heat is before burning. Here is the same heat is in the room after burning. But here it burn, but here it doesn't burn. Why? Here, this energy is useful when we can use it to do the work. But this energy which is spread, it cannot be more useful. It cannot be used to cook the food. Can you cook the food by putting in room? You say, oh, the same heat is here, so ultimately it will cook my food. No. And if you put your food here, it will cook. So this is a useful energy. So scientists think what is happen here? It has more tendency to do work. When it is spread, its density decrease. Its ability to do work is also decreased. So we use a Newton entropy. Okay. So if entropy increase, it means energy is spread. It is no more available to do the work. Okay. Okay. By the way, you know, engine, it burn the fuel, gasoline. Is all chemical energy converted into mechanical energy? No. Where the rest energy go? Heat. And heat energy is exhaust in the atmosphere surrounding. That is a waste energy. Cannot be converted to work. So that wasted energy is calculated in terms of entropy. So students, you cannot convert all energy into work. Okay, useful work. Some energy is wasted. That is used to increase the entropy of this universe. So it means increase the randomness. Okay. So basically, entropy is the dispersal of the energy. Here, energy is more condensed, entropy is less. If heat is spreading, energy is spreading, entropy is increasing. Okay. Okay. But how you decide the entropy is increasing and decreasing? So we have one criteria, randomness. But I will show you some example where randomness is increasing. That is not only the criteria. Sometimes randomness is not changed, same arrangement, but still entropy is increased or decreased. Okay. So students, if randomness increase, entropy decrease. If entropy increase, randomness. If entropy increase, randomness. Don't rely on this one. I am asking if entropy increase, randomness increase. Okay. Students, entropy is a state function or path function? Its symbol is small or capital? So it means it is definitely and it is easy to calculate because it only depends upon the state. Finally, if you know two values, you can calculate how much change. Students, can you measure the heat? Can you measure the work? Can you measure the potential? You can. But entropy cannot be measured. We have no instrument which we put in this room and measure the entropy of this room. We just calculate practical entropy by using some other values. No instrument to measure this entropy. Okay, this is the part that which is more arranged, A or B? A. Which has more entropy? Which has more entropy? B. More randomness. Okay. But student, practically both have the same entropy. Okay. Okay. So entropy is the second definition. More precisely, we can say entropy is the measurement of the number of possible microstates. Number of possible microstates. If any system has more microstates, we say this system has more entropy. For example, I have a coin P. In Chinese, we say P. I have a coin. So if I toss a coin, how many possibilities it has? This. So it means it has two states. 50%, this one 50%. It has two states. If I have a Roman cube or dice, it has some sparks on it. So if I toss this one, how many possibilities? So it has more chance of randomness, okay? It has more entropy as compared to this one. It is 2 microstates, 2 states. It has 6 states. If you toss, you don't know, but you sure it is one of that 6, not 7 or not 8. So more states, more disorder, more entropy, okay? In our room, if we increase the number of chairs, then your seating plan is more chance. You can sit today here, maybe Benson next time here, here. So, by the way, when you come every day, if you are changing your positions, okay, it means you are changing your microstates. System is same, but you have a many number of seating plans. This student can sit here, here, here. So many plans, okay. So in this class, we have a lot of combinations of seating. Which means this class has a lot of intro as compared to small class, okay? If we remove that, okay. Car, in car, how many seats in the car? 4 or 5, and in bus. So which has more seating plan possible? Bus. So it means in bus, people are more entropy, okay, if they are sitting there. Okay, so there are two type of disorder. One is a position disorder and second is thermal disorder. Okay. So entropy is measured. It is represented by S. It is linked with different properties. So let's learn. Okay. So student, if you have a two dice. So if you toss them, how many chance both have one? How many chance? Only one possibility. Okay. If you toss a dice, two dice, roll them, how many chance you get a 3 number? Maybe one has 2, another is 1, 2 to 3. Maybe the first dice has you 1, another is 2. So how many possibilities? 2 possibilities. So to get this number, you have 2 possibilities, 2 microstates. Okay. How many chance to come 4? This combination, this combination, this combination. It means chance are probability is this one. Probability increasing. How many chance you get the 7 score? 6 probability, so 6 combination, okay? Maybe one is this one, second is this one. Maybe one dice show this score, second this score, 7, 7. So you have more chance to come this combination, okay? Because its probability is more, because its microstates are more, okay? So students, microstate, you understand the microstates? So basically entropy means any system if it has more microstates, we say its entropy is high. Any system whose microstates are less, we say its entropy is less. Okay. So let's learn about the entropy in detail. The video is
Entropy, or S, is a measure of the randomness or disorder of a thermodynamic system, such as the randomness in the arrangement of atoms, molecules, or ions. The greater the disorder in a system, the higher the entropy. Entropy is a state function, which means that the change in entropy of a process can be calculated by finding the difference between the final state and. So maybe you go from this state to this state by this path or that path. It doesn't change, it doesn't affect. The change is the same, okay? It is a state function, not the path function. The initial state, regardless of the path taken. The entropy of a system can be expressed by Boltzmann's equation. So this is the formula. You can calculate, not measure by instrument, but calculate by using this formula. So this is the Boltzmann's equation, okay? In which S is equal to Boltzmann's constant K multiplied by the natural log of the number of microstates W. So these are the two parameters. K is a constant and W are the microstates, okay? Today you are sitting in this room. This is the one microstate. If I ask you to shuffle the seats, that will be the next microstate, okay? Seating man. So coin has, how many coins have the microstates? 2. So if you put here 2, multiply by this constant, then you can calculate the entropy of this one. And next lecture, I will ask you to calculate the entropy of this cube, okay? Microstates are the distinct energetically equivalent configurations that are possible for the atoms and molecules in a given system. Consider a system that contains 2 atoms with a total of 2 units of energy. This energy can be distributed between the 2 atoms in 3 different ways. Both units with the first atom, both units with the second atom, or 1 unit with each atom. Thus, this system has 3 potential microstates. So this is a seating plan. Diatomic molecule, and it has, for example, this is suppose 2 energy units. So maybe both energy units contain 1 atom, second has 0. Maybe second has both, first one is 0, or maybe both has 1, 1. There is no third possibility. So it has 3 microstates. All of which are energetically equivalent. It follows that entropy increases in proportion to the number of atoms in a molecule and its molecular weight. So this is number and molecular weight. So entropy increase with the number of atoms. If I ask you 2 molecules, in one molecule number of atoms are more, it means it has more entropy, okay? Even at the same temperature. Secondly, molecular weight. So if I say helium, neon, argon, which atom has more entropy? So both have a same number of atoms. So its molecular atomic mass or atomic weight is higher. It has more entropy, okay? So you learn 2 things. For example, under standard conditions of 25 degrees Celsius and 1 atm, the entropy of 1 mole of sulfuric acid is greater than the entropy of 1 mole of water. Additionally, the entropy of a mixture is greater than the entropy of its pure components. So students here, when it is a pure form, and then you add any solute, then it becomes mixture. In mixture, volume increase. When you mix 2 things, volume increase and this order increase, okay?
So it means entropy is also directly proportional to volume. More space, more entropy. Okay.
As increased complexity results in a higher number of possible microstates. The entropy of a system also increases with temperature. As the temperature increases, so does the kinetic energy, resulting in an increase in the number of possible microstates.
So it means if you increase the temperature, entropy increase. Okay. So in winter, so temperature is low, it means entropy is low. In summer, temperature is high, it means the entropy of the same system will be high. For example, if you have a flask in the classroom, if its temperature is higher, it means its entropy is higher. Okay. So we have learned entropy is directly proportional to number of atoms, molecular weight or atomic weight, volume, and temperature. Okay.
The physical state of matter is an indicator of a substance's relative entropy. The entropy of a given solid is always less than the liquid form of the same substance, and the entropy of the liquid form is always less than that of the gas.
Students, if you melt this one, you provide energy. It means it has more energy. More energy means more entropy. Secondly, here atoms are more arranged. Here are more disordered, Okay. So gas if the same system convert from solid to liquid, its entropy increase. Okay. So entropy also depends upon the state. But state is not, we cannot say it is directly proportional. It depends upon the state. Okay. Same material in gaseous form. Gaseous form is always high entropy as compared to its liquid. And liquid has high entropy as compared to its solid. Because in solid, they are more arranged.
The molecules in a gas are far apart from each other and have many more possible microstates compared to molecules in a liquid or solid. Solids, on the other hand, are much more organized with fewer microstates, thereby resulting in lower entropy.
So any question related to entropy? Do you understand? Okay, so it's your turn. Under what condition is standard entropy measured? Standard entropy means if we put this on entropy change, what conditions? Which is 1, 2, 3, 4. 4, 1 atm and 273 Kelvin. I think this is the standard condition. So if you measure the entropy at this condition, that is called standard entropy. So okay, the which statement is a true? And this person. Okay. Sit, stand. Okay. 2, stand up. 1, sit down. 2, stand up. Okay. So what is which statement is true? Which first, second, third, fourth. 1, 2, 3. More microstates possible, less entropy. That is true. Which statement is true? Okay. So students, I think second is not the correct answer. According, because entropy is directly proportional to microstates. W means microstates. More microstates means more entropy. So it is not true. It is not true. It is false. So you have to find the statement which is true. Okay. The last one, student. Which statement is true? You can find here any relation with entropy. Yes. Which of the following statement is true? Entropy is inversely proportional to number of possible microscope. Inversely proportional means more microstates, less entropy. This is, I think, not true. Nelson?
Proportion to.
Inversely proportional. Inverse means this one.
Yeah, I know.
Is this true?
No.
This is not true statement. You have to find this true statement. Lower the temperature, lower the entropy. If this is lower, this is
No.
answer is 3. Okay. Find this order. You have a monatomic molecules are these are the noble gases atoms. So you have to find the correct order of increasing entropy. 3. So entropy, what is the relationship of the entropy with atomic weight or molecular weight? If any atom has high molecular weight or atomic weight, entropy is high. So which is the heavier? Helium, neon, argon, krypton, xenon. So xenon is the heavier. So it means its entropy is highest. So krypton is second. So I think this band is suitable, huh? Are you agree? Okay. So students, reservingly in solid entropy, I am not comparing one solid and different liquid and different gases. No. If the same material is in the solid form, same material convert into liquid and into gas, then we can compare. Okay, when it is in solid form, its entropy is less. In liquid form, its entropy increase. And solid gases form, its entropy is further increase. Because you provide the energy, energy is dispersed. And more randomness. Okay. Students, entropy change. If entropy is increased, then delta S is positive. Delta S is positive. If entropy decrease, delta S is negative. We cannot measure the absolute entropy, this one. We cannot measure. And it cannot be never negative. So this entropy is 0 onward. Like temperature, Kelvin temperature is start from 0 to onward. So Kelvin temperature is not negative. Similarly, absolute entropy is not a negative, but change in entropy may be positive or negative. So it may be positive or negative. What is mean by negative entropy? Negative entropy means entropy increase or decrease? Decrease. And positive entropy change, delta S is positive means entropy increase. Okay, students, in which system the molecules are more ordered than solid, liquid, or gas? Water. Solid due to hydrogen bonding. So it means intermolecular forces also help to predict the entropy. Okay, if two system, two liquid, everything is same. One has more intermolecular forces. It means its molecule are more arranged. Entropy higher, less, less. So intermolecular forces, more intermolecular forces, less entropy. Intermolecular forces are attractions are okay. Okay, this is the conclusion summary. Students, this is the entropy with the time. So entropy is never zero, okay? So it always start maybe never less than zero. It is minimum is zero, but here it means at this condition its entropy is this one. With the passage of time, if entropy increase, it means reaction is spontaneous. Students, what is the use of entropy? Entropy is actually help us to predict reaction is spontaneous or non-spontaneous. This does not tell us. But this is a very good criteria to tell entropy is increasing or spontaneous or non-spontaneous. But this is not only the system. No, it means if you know entropy of universe, which is entropy of system plus entropy of surrounding. If you know this one, then you can predict reaction is spontaneous or non-spontaneous. If it is positive, spontaneous reaction. If it is negative, non-spontaneous. This is the criteria. Easy. So its use is this one. So students, all natural processes are spontaneous. All natural processes are spontaneous. It means if they are spontaneous, their entropy with the time is increasing or decreasing. If entropy is a positive, reaction is spontaneous. If reaction is spontaneous, entropy is positive. Positive means increase. So it means all natural process, entropy is increase. So actually, this is the second law. The entropy of the universe is increasing, of the natural process increasing. You are actually stating the second law of thermodynamics. Students, whenever the entropy is increasing, reaction is spontaneous. When it doesn't change, not decrease, not increase, then it means reaction is at equilibrium. Then reaction is at equilibrium. So in equilibrium reaction, entropy doesn't change. Okay. So if in forward reaction, if it is a disorder, in reverse reaction, same order. So it means overall no entropy change. So if entropy change is zero of the system, it means there is an equilibrium position. If entropy of the system is greater than zero, it means reaction is spontaneous. Because in spontaneous process, entropy is increasing. Okay. Okay. So entropy is due to two things. Due to position and due to thermal. So in next lecture, I will explain you. Okay, this is the position entropy. When you mix two things, their positions are changed. Due to their position change, entropy increase. And second is a thermal entropy. Due to thermal energy, entropy increase because number of atoms are remain same. Particles are same. Their position is not changing, but entropy is increasing. So this is called thermal factor. So next lecture, we will discuss this one in detail, okay? Thank you very much. If you have any question, please ask me. Any question?
I have a question.
Yeah.
About yesterday's class.